So here we have a word problem. A first grade class was going on a trip to the amusement park. 12% of students did not go. So I'm going to circle this 12%, and then I'm going to label it as percent of students that did not go on the trip. The next sentence says 132 students went on the class trip to the amusement park. So I'll circle 132, and then I'll label this as the number of students that did go on the trip. And the next sentence is the question we're actually being asked. So let's underline that. So they're asking for how many students. And when they say how many students, it sounds like they're asking for the total number of students. So let's make a note of that. Now that I have all of my information, and I know that one of the values is a percent, I'm going to be dealing with ratios, which means it's a good idea to start by drawing a ratio table. And whenever I'm dealing with percents, I always tell my students to put one column for the percent values and one column for the actual number values. Then on the left, I always tell my students to write part and whole. This is going to represent the specific part we're talking about, and this is going to represent the whole group of whatever it is we're talking about. And let's take our values and start by putting them into the table. So is 132 a percent? Not at all. So we're not going to put it in the percent column, which means it has to be in the numbers column. But will it be in the part box or the whole box? Well, this is only talking about the students that did go, not all of the students. So it can't be the whole value, which means we'll put the 132 where it's the number part. And I'm also going to make a more specific label, because the 132 is talking about the students that did go on the trip. And here we have 12%. Since we have 12%, normally we would put that here, but we have to read carefully. Because these are in the same row, both of these, the number and the percent, should both talk about the students that did go. But the 12% is talking about the percent of students that did not go. Let's say that this whole bar here represents 100% of the first grade class. And we said here that 12% of the kids did not go on the trip. So let's make a small section for that. So this small percent here, 12%, represents the first graders that did not go on the trip, which means that the rest of this represents kids that did go on the trip. Now, what's the value of this big piece here? Well, if everything's 100% and 12% represents the kids that did not go on the trip, then how would we find this? Well, we could subtract this 12 from 100, and whatever's left is the value of this big piece here. So let's do that math. We can't do 0 minus 2, and we can't borrow from the 0 because we can't borrow from nothing, which means we'll have to borrow from 1. This 1 will become 0, which makes this 10. But then this 10 we're going to borrow from, make that a 9, and then make this a 10. Now we can subtract. 10 minus 2 is 8. And 9 minus 1 is also 8. Which means that this big piece, which represents the number of students that did go on the trip, is worth 88%. And since the top part of our ratio table is talking about students that did go, we're not going to put the 12%, because again, that talks about the kids that did not go on the trip. And since we want the percent of kids that did go on the trip, we're going to put 88 here instead. Now let's take a look at the bottom row. Now we're talking about the whole. Well, remember, when we're talking about percents, the whole value is always out of 100. So we'll write 100 in this box here. And it's a good idea to be more specific, like we were up here. The part is talking about the kids that did go on the trip. The whole is talking about the total number of kids, or the whole first grade class. And remember the question that we're being asked. We actually said it here. We're looking for the number of students in the first grade class. Since that's what we're looking for and we don't know what it is, in this box we'll put a variable. I'm going to pick the variable t for total. Before we go on, please make sure you have all of this copied down, because I've got to get rid of it to make more space for our next steps. Normally when we get to this point, we would cross multiply and multiply 88 times t and 132 times 100. But these numbers are huge, so I don't think it's a good idea. If we look at 88 over 100, that's really a fraction, and both of these numbers are even, so I would recommend reducing if you can. So I'm not sure if you know this or not, but this column here is just a fraction. In fact, it's the fraction 88 over 100. So I'm going to write that here as a fraction and then reduce or simplify it. So the numbers we have here are a lot smaller and a lot easier to work with. So we'll write 88 over 100. So right away, what numbers do you think can divide 88 and 100? They're both even, so right away we should know we can divide both of these by 2. 88 divided by 2 equals 44. 100 divided by 2 equals 50. So our new fraction so far is 44 over 50. But I know that I can reduce this by 2 again. So let's go for it. 44 divided by 2 equals 22. And 50 divided by 2 equals 25. So my new fraction is 22 over 25. So instead of using 88 and 100, let's get rid of those and replace it with 22 and 25. Make sure you got all of this, because we have to erase it to make more room for our next steps. So now that we have smaller values, let's cross multiply. We've got 22 times t, which gives us 22t. We'll write our equal sign, and then we'll cross multiply the other way. We'll multiply 132 times 25, and then we'll bring that result and put it down here. So let's do that work on the side here. So first, we're going to multiply each of our values here by the number 5, and then we'll repeat the process and multiply everything by the value 2. 5 times 2 is 10. I'll bring down the 0 and carry the 1. 5 times 3 is 15. Plus 1 is 16. I'll bring down the 6 and carry the 1. And finally, we've got 5 times 1 is 5. Plus this 1 is 6. We've finished multiplying everything by 5, so I'm done with that. And then I like to put a placeholder underneath that value. I like to put an X, but you can put a 0. Either way, it doesn't matter. The key thing is to make sure that now we start writing our values under this 2 here. That's why that's here. I also like to cross off anything that I carried before. That way we don't confuse it with anything we might carry now. So now we can get started. 2 times 2 is 4. 2 times 3 is 6. And 2 times 1 is 2. Now that I'm done multiplying everything by 2, I'm done with that. And now I can add 0 plus 0 is 0. 6 plus 4 is 10. I'll bring down the 0 and carry the 1. 6 plus 6 is 12. Plus the carried 1 makes 13. I'll bring down the 3 and then carry the 1. And 1 plus 2 is 3. Giving us a final answer of 3,300. Now let's write that in here. So step 1 was to cross multiply, which we did. Step 2 is to divide both sides by the coefficient. In case you don't remember, the coefficient is the number in front of the variable that you're multiplying it by. So this really means 22 times t. So now we'll divide both sides by 22. And we show that by drawing a line under both sides and writing 22 underneath. These 22s will cancel, leaving t by itself, which is exactly what we want. And then we'll divide this side by 22. But that's going to require some math, and we can do that over here. And since we've got 4 numbers in our dividend inside the long division notation, we should make sure that our quotient, or the answer, has 4 digits on top, even if the digit is 0. So first question, can 22 go into 3? The answer is no, which means it goes in 0 times. So we'll write a 0 over the 3. Then we'll try this digit and the next digit together. Can 22 go into 33? Yeah, it can go in 1 time, because 1 times 22 is 22. We'll put that here. When we subtract, we've got 3 minus 2, which is 1, and 3 minus 2 again, which is 1. Once I finish my subtraction, I bring down the next digit, which in this case is 0. So I'll bring down the 0 and divide this value, 110, by 22. Let's get rid of this old work to make room for our new work. So how many times do you think 22 can go into 110? When I have a 2-digit divisor, what I like to do is start by multiplying it by 5. If my answer is too big, then I would try something less than 5. And if it's too small, then I will try something more than 5. So let's get started. We've got 22 times 5, and that will give us, well, 5 times 2 is 10. I'll bring down the 0 and carry the 1. 5 times 2 is 10, plus this 1 is 11. Well, that is awesome. We actually ended up with exactly what we need. So we're going to put 5 on top of the 0, and then write down 110 right here. When we subtract that, we get 0, which is exactly what we need. But do not forget, we still have 1 digit remaining. So we have to bring that down and repeat the process. So we'll bring this 0 down, and then divide 0 by 22, which gives us 0. And that'll be 0, I'll subtract, and when we do that, that's just 0. And so we're finally done. And this gives us our answer, 150. So t equals 150. But what does this mean? 150 what? Well, remember, we were looking for the total number of students in the first grade class. So this means that there are 150 total students in the first grade class. And just like that, we are done. I hope this video helped. and I hope you feel a lot more comfortable with percents. Thanks for watching, and we'll see you next time on the Math Review.